Hello everyone, I'm Monica and I'm a PhD researcher at Penn State University. I am starting a new YouTube series specifically targeting the beginners who wanted to work on reverse engineering or binary analysis. In these videos, I assume that you have a basic background on computer science, or at least in writing C programs and what GCC and the compilers is. Let's start. So today I'm going to discuss about what is a binary and how the binary is generated. As the name suggests, the binary is nothing but a combination of zeros and ones. So modern computers perform their computations using binary numerical system, which expresses all the numbers as strings of zeros and ones. And the machine code that these systems execute is called binary code. So we all know about application binaries, right? For example, when we want to install Firefox, we download it from the web and then we installed it. That is nothing but a binary which is getting installed in your system, and deep down that binary is nothing but a sequence of zeros and ones. So now let us see how the binary looks like and how it is generated. Considering you have a basic background on C programming, we all know what this program is. As you can see, this is a basic hello world.c system, C code, which is doing nothing but including a header. And it also have some has defined statements, and it is just calling this int main function, which is doing nothing but doing a printf on this format string and message, which is nothing but it is printing this hello world string, and we have a return 0. So we know what this is called. This is called source code. So to generate out of this source code, what we do, we feed it to this compiler. So we know this GCC compiler. This is a very famous compiler for C. Other than GCC, we also have Clang and etc. etc. Once this compilation process is done, we got a executable, which is nothing but the default name is a.out in Linux system, and this is what we call as binary. So this is the whole process of generating a binary out of a simple source code. Today, what we want to do, we want to deep dive into this compilation process of this GCC or any compiler, and we want to see how a binary is generated out of a source code. Now, let us go into the detail of a compiler. So let's see what is how the C compilation process looks like. This compilation process is majorly divided into 4 steps: name, pre-processing, second, compilation, 3, assembly, and 4 is called linking. This is the major 4 step of generating a binary. Let us see now how these steps are combined together to generate a binary. If I have to draw a diagram or the pipeline of a C compilation process, so we'll all know in the beginning, we have some source code. We can have one source code, or we can also have multiple files. For example, we have these 3 files in our system. Just to make the project more manageable and human readable, developers usually divide their code in 3 or multiple files so that they can modify it easily later also. And if they're modifying only one file, they don't have to compile all the files again, which can be a time consuming process sometimes. So at the beginning of this, we have this source code. And what we do, once we have the source code, we feed all the source code to our pre-processing phase. And as we also see in our hello world problem, we have this basic header inclusion, which is stdio.h. There can be multiple headers also. So we also feed these header files to our pre-processing stage. So the job of the pre-processing phase is, so if I write it down here, the job of this phase is basically macro expansion and file inclusion, etc. So what does it mean? So if we again go back to our initial C program, you can see that we have this hash include stdio.h, that is file inclusion, and we have also used this macros called format string and message. So the job of the pre-processing step is to actually replace the content of the header files and expand the macros so that it will be easier for our compilation process to generate assembly code. So once the pre-processing is done, now we feed it to our next step, which is called C or C++ compiler, such as GCC. The job of the compilation process is to take whatever the pre-processing phase is giving you and then translate into assembly language. So if I again write it down, the job of the compiler is to generate assembly language. Now, you may ask now why we are generating in between, that is the assembly language, why we are not directly generating the binary. So to answer to that question, we have multiple programming language, right? Like C++, Objective-C, Common Lisp, Delphi, etc. So it is very difficult to generate or write a compiler for each of these languages. So that is why the researchers had come up with that idea where the compiler generate an intermediate assembly language, and then on top of that you have other phases which will translate into machine code depending on what kind of language it is. So once the compilation process is done, now we have this next phase is called assembler. So the job of the assembler is to take this assembly level code generated by the compiler and then transform it to object files. Now, it's an important thing to notice is that for each file, you will have one object file. So for example, for this file1.c, we'll have file1.o, and similarly for file2, we'll have file2.o and file3.o. The one other thing to notice is that, so each of these objects are individual and directly created from these C files. So if there is some interlinking between them, then this objects file do not know that because they have been assembled separately based on each source file. So to come, and we know that all of these files are combinedly doing one task. That means we are expecting one binary. So once we have each module for each source file, we'll need another phase, which is nothing but called linker. This is the last phase of the compilation. And in the linker, we feed all of our object file along with our libraries. So the job of the linker, so if I write it down, the job of the linker is to create single or one binary file, which the operating system can directly load into and then do the required processing of it. So at the output of the linker, we will have our binary, which is this a.out by default. But if you want to change the name, you can change the name also. Okay, so again, if I have to reiterate, we have our source code First, we feed it to our pre-processing along with the header file. Pre-processing will expand all the macros and the files. Then it will give it to compiler. The compiler will generate assembly level language. The assembler will take the assembly level language and generate object files from it. Then the linker will add the libraries and these object files and link them together like a puzzle solving, and that will give you the binary. So this is the whole compilation pipeline of how binary is generated out of C file. Now, just another thing is left is that, so is the libraries. So linker attached libraries plus these object files, right? Now, libraries can be of two types. One is static library and another is dynamic library. So if we talk about Linux system, the static library may look something like that. For example, the library name is libabc.a. This is how the extension of the static library is. The important part is .a. And for the dynamic library, it can be like libabc.so. So is nothing but shared object. So depending on the extension, you can see what kind of library that binary requires. So if this is a static library, that is the binary is referencing to a static library, then the whole code of the static library will be included in the binary, and later when the binary is loaded into the system, there is no external symbol resolve is needed because the binary, that library code is already inside the binary. But if it is a dynamic library, it is critical because in dynamic library, multiple binaries shared a common library which is loaded into the system. So that symbolic resolution is not been done in the compilation process. So that symbols will be there in the binary, and later when the operating system load the binary, it will resolve those symbols and which will directly point to the dynamic library. Okay, so this is how the compilation looks like. We have a source code, we feed it to the compiler, and we have the binary, and which is divided into 4 phases: pre-processing, compilation, assembly, and linking. And this is how the whole compilation pipeline look like. This is it for today, and next day we'll be seeing a practical example of how this compilation process is executed. For example, we have the source code. We'll see what is the output at every step. That is, what is the output after pre-processing step, or the compiler step, or the assembly, or the link. That's for it today. Thank you guys for listening. See you in the next video.